Good morning. Welcome all of you to the new session of classes on circular motion by the virtual classes of Scientia. I am Shabu Subramanian signing in so that we can all study the concepts in detail. I would like to say my explanation will be in English, but I will try to explain it very slowly such that anyone who is watching this video will be able to understand the concepts in detail. Because if you want to write the language exams in the particular language, it will be better for all of you to learn the subject in the same language itself. So let us enter into the concepts first of all that are related to the circular motion of a particle. We will be seeing uniform circular motion, we will be seeing non-uniform circular motion, and we will be discussing all parameters related to the particular concept. So, circular motion of a particle or motion along the circumference of a circle. Here we have to learn the fundamental aspects which all are useful or will say beneficial for us to enter into the concepts of rotational dynamics as well. So I would like to divide this board into two sectors. This side will be for our explanation and this side will be for us to make the final results, and this side will be for making diagrams. Circular motion for us to learn. So suppose a particle is revolving along the circumference of a circle of radius, say r. We all know that radius is a vector quantity. This is, I would like to say, this is a top view of the circle. I will give you another type of view as well, which is a side view. Or this we can call it as the axis of the circle, because in many textbooks the way of diagram will be different. So all the students who have seen this diagram as well as this diagram can follow this class in an easy manner. So we have a circle which is centered at O and has got a radius r, and I am going to give you the basic ideas of circular motion. The first one, as all of you know, that the time period. The time period of motion. As time period is represented by capital T. What is time period? If the particle starts from this point and if it is moving along the circle like this, suppose we are assuming that the particle is moving such that an anti-clockwise manner. If I am looking from the top, if I draw that one over here, that will look like a arrow mark like this. So that is an anti-clockwise circular motion. So if the particle is moving like this, the time taken by the particle to complete one full revolution, so time for one full revolution is known as time period. Obviously, this is represented in seconds, and its dimensional formula will be equal to t to the power 1. This is the very basic aspect that we must have studied in lower standards. Now, the next concept for us is the frequency of revolution. Frequency of revolution, represented either by f or the symbol nu. So frequency, as the same frequency name indicates, we all know that frequency is something which is repeating after some time, we can say. So we will be denoting that one as frequent interval, something like that. So the frequency is nothing but it is, if it is making t, if it takes t time to make one full revolution, this is nothing but this is the time taken for one revolution. So the time taken, the number of revolutions per second. This is the number of revolutions per second. So that is equal to 1 over t. The unit will be second to the power minus 1, and this is generally expressed in SI unit by heads. Symbol is H sec. So the dimensional formula will be T to the power minus 1. So that is the basic aspect that we must have studied in lower classes. Now I am entering into the first concept that we need to learn in the unit of circular motion, that is nothing but that is called as the angular velocity. Velocity concept, that is angular velocity. What is velocity of a particle? Velocity of motion is defined as displacement divided by time taken. Displacement divided by time taken. So suppose the particle completes one full circle, it moves one full circle. What is the total angle covered by the particle? The total angle covered by the particle is 2 pi. The time taken is t. We can call this one as what? Total angular displacement divided by total time taken. That is known as angular velocity. This is also called as angular frequency. Angular frequency. How you can say angular frequency? Angular frequency is the angle covered in 1 second. The total angle covered in 1 second, or that is the angular displacement per unit time. Angular displacement per unit time. Angular displacement or angle covered by the particle per second. The unit will be, as angle is represented in radians, this will be radian per second. That is the way to represent which one? Angular velocity. Now I am entering into brief the concepts of the motion. For that I am making a particular column. As always I would like to do with the physical concept, I am making parameters in one column. Parameters of motion in one column. I am leaving one column for linear parameters, so that we can observe the linear parameter in one column and angular parameter in other column, and let us see whether there is any relationship between linear motion and angular motion. So we got angular velocity, that is called as the frequency or the angular displacement. Now suppose the particle starts the motion from this point. I am calling that point as T1. It is moving anti-clockwise. This is at this point at T1. It moves to final point T2 at a later time T2, such that it makes an angle, say delta theta during that interval. Delta theta during that interval. We can say that the particle has made a length of r, that we will call it as the linear displacement. So when the particle moves through the circle, it has covered a linear displacement, because the arc length can be expressed as s. So linear displacement is expressed by s, which is the length of the arc. During the same time, what happens? It makes an angular displacement of delta theta, or we will say the angle covered by the particle. Now we are into the first relation making of the circular motion, that is, we all know the basic relation of mathematics, that angle is equal to r divided by radius. Angle is equal to arc divided by radius. So I can write delta theta is equal to s divided by r, or we may also write s is equal to delta theta times r. And as this is a vector quantity, r is also a vector quantity. Delta theta, you all know that angle is a polar vector, so this is also another vector. So s can be expressed as the cross product of delta theta and r. So we got the three directions for the particle. So we can represent delta theta is making anti-clockwise motion and delta theta is pointed upwards. Delta r is towards through the radius and s is along the tangent. So we got three directions. Delta theta is along the axis, r is along radius, and displacement is along the tangent. So all of them are mutually perpendicular. All are mutually perpendicular vectors. So I got the first relation, how the vectors are related. The linear parameter is equal to angular parameter multiplied by the radial vector. So I can write S is equal to delta theta cross r. That is my first relation. That is the displacement column is over. Now we are into the next concept. When we have studied the displacement, obviously our problem is to find out what? Velocity, the concept of velocity. So the velocity has got two aspects as we already know. One is the linear velocity. Linear velocity we can represent it as v. And what is the displacement of the particle? When it is moving from P1 to P2, the displacement is nothing but that is the arc length. That I am writing it as S. Let the time taken is equal to delta t. So we can represent v is equal to S divided by delta t. We have got the same direction as S, or we can say that the direction of the velocity is along the tangent. Direction of velocity is along the tangent. So if I denote that one over here, the velocity will be into the plane of the paper. R is along the radius. So we can see the velocity is tangential, or I may represent the linear velocity as tangential velocity as well, or you can call the velocity as tangential velocity. Now the next concept, when the particle is executing the displacement of S, it also makes an angular displacement of delta theta. So we already have seen angular frequency or angular velocity concept. What is angular velocity? We all know that omega is equal to delta theta divided by delta t. My question is whether omega is a vector or a scalar. You already told that angle is a polar vector. So this has got a direction, so omega also should have the same direction. So when this is making an anti-clockwise rotation, theta is upward, so we can say omega also will be upward. So when this is making this type of a motion, you will be seeing in any textbook that omega is upward. So we have got for anti-clockwise direction, omega is upward. For clockwise direct rotations, omega will be downwards. So we got omega, which is delta theta divided by delta t. Now, whether there is any relationship between that two. A relationship between V and omega. We got S is equal to delta theta times delta R. The equation 1. The linear displacement is equal to delta theta cross R. What is tangential velocity? Tangential velocity is S divided by delta t. Substituting, you will get delta theta cross R divided by delta t. So from this I can take delta theta divided by delta t. What is delta theta divided by delta t? That is nothing but omega. So we may represent that one as omega cross R. Vt is equal to omega cross R. Second relation. So we got all the velocity concepts. Velocity, linear or tangential, is S divided by delta t. Next is angular. Omega is equal to delta theta divided by delta t. And the relation is Vt is equal to omega cross r. Second equation, my velocity column is over. Like the other parameters of displacement, we can also say Vt, omega, r, all are mutually perpendiculars. You got the directions. So that completes the discussion of velocity concepts of the particles. Now we are into the next aspect, that are concepts of acceleration. Concepts of acceleration. When you are studying acceleration for circular motion, this has got many aspects, so we have to be having different columns for this, because for any particle acceleration can happen in two ways, that is velocity acceleration. All of you know that acceleration is nothing but it is the rate of change of velocity, or delta v divided by delta t. As velocity is a vector quantity, its direction can change or its magnitude can change. Suppose the magnitude remains constant, we will call that type of motion as uniform motion. If the magnitude is not changing, we will call that motion as uniform motion. So we will call that motion as uniform circular motion. In this, what happens? Only the direction of velocity is changing, whereas the magnitude always remains constant. So we can say, if the velocity has got a value v1 over here, this has got the same value v1. That means magnitudes of velocity at different points are the same. But what happens when the particle moves from p1 to p2? Its direction is continuously changing, because we know that different points on a circle, the tangent will have different directions. So let us try to analyze that velocity or that acceleration. So when the direction of velocity is changing, we are getting an acceleration for the particle. So acceleration of this type is common for uniform circular motion as well as non-uniform circular motion, because in any circular motion the direction of velocity will be continuously changing, and this acceleration is called as centripetal acceleration. Centripetal acceleration. Now we are going to analyze this one in detail. Suppose we have a particle executing circular motion. Let this be at different points at different instances, and let this is the radial line. Let this be point P1, where the velocity is v1, and this is at the time t1, and this is r1 vector, and let this be p2 point, where velocity is v2, time is t2. The velocity at this point is v1, let it be directed like this, and velocity at this point is v2, directed like this. Let this point is having r1 and this is equal to r2. As we have studied this one as a uniform circular motion, I can say that magnitude of r1 is equal to magnitude of r2 is equal to radius, because radius doesn't change. And as it is uniform circular motion, only the direction of velocity is changing, so the magnitude remains constant. v1 is equal to v2 is equal to v. Magnitude of v1 is equal to v2 is equal to v. Now our problem is to get the difference of the two, or we have to find v2 minus v1 or v1 minus v2. So we have, I am plotting the vectors onto a parallel, I am shifting the vectors parallelly, because vectors can be shifted parallelly. If v1 is like this, I am plotting that one on this line like this, v1, and v2 is like this. I am plotting v2 over here. So one vector is v1, other vector is v2. We have got the third side of the triangle. If two vectors are meeting in this fashion with the tails together, the third side is obviously nothing but the difference of the two vectors, which is known as the triangular law of vector addition. According to the triangular law of vector addition, the third side is the difference of the two, and the difference is directed from v1 to v2. The direction of difference is from v1 to v2, or I can say this side is equal to delta v, which is equal to v2 minus v1. How we got this? We have v1 velocity at this point, v2 velocity at this point. This is r1 and this is r2. I have plotted v1 onto this line as well as v2 onto this line. The difference is v2 minus v1, and that is directed on the line towards the center. We can say this is directed towards the center of the circle. That is why this is called as centripetal acceleration, because the acceleration is seeking the center. It is searching for the center. Now let us try to get the value of that one. What is centripetal acceleration? Acceleration is delta v divided by delta t, and the direction we already have got, so I can remove the arrow mark because this is directed towards the center, directed to center O. Now our problem is to get the value of that acceleration AC. We have one triangle over here. I am representing this triangle as, say, this one is O and this one is R1 and this one is R2. I am completing this triangle. So we got one triangle OP1, P2, and let this be, say, A, B and C. We have two triangles in my diagram. One is OP1, P2, the other one is ABC. OP1, P2 and ABC are like, they are similar triangles. So we can say the ratio of the sides will be equal. We can represent from triangle ABC, one side is delta V, any of these sides will be equal to V itself. So delta V divided by V is equal to, from this it is equal to delta R divided by R. Substitute into the expression of AC. What is AC now? Delta V divided by delta T, or from this delta V can be written as V into delta R divided by R. So V into, or V by R into delta R divided by delta T. Delta R divided by delta T is nothing but that is again equal to V. So we will get this expression as V square divided by R. So centripetal acceleration is derived as V square divided by R. I am putting it as equation 3.